The topic is ASCII codes and Unicodes. We will learn about this topic as a very fresh topic. I'll explain you from the very basic concepts. Let us know a few things for understanding this ASCII codes and Unicode. See, the very first thing is that our computers can understand binary code. They can understand binary code. Their language is binary language. Whatever the data that we provide in our computer system, that will be in the binary form only. For example, if I have a number 10, value 10, then it is stored in the form of binary, that is 1010. So this is numeric, and binary number system is also numeric. Now the question arises how our computer system understands alphabets, letters, English alphabets. Because computers can understand only the data in the numeric form, then how we can make them understand alphabets? So the solution is, for English alphabets or all other characters, we define some codes. Let us say 65 is actually numeric value. But if we say this is not number 65, we say this is letter A. But how does a computer system understand that this is number 65 or a letter A? So we mentioned that this is a string type. We say that this is string type or character type. So it will not treat it as a number, but it will take a picture of A. So now let us make it clear. See, if I am giving a number 10, then it is number only. But if I am giving some other number and saying that it is not a number, it's a code. If I say it's a code, then for that, there is a mapping alphabet. So computer system follows the codes, that is numeric codes for alphabets also, characters also. So for English language alphabets as well as all the special characters and the numbers, there are some codes defined, and those codes are followed as standard codes. So those codes are called as ASCII codes or ASCII codes. This means American Standard Code for Information Interchange. You can Google it and you can find out the full form of this one. Again, I repeat, American Standard Code for Information Interchange. So for every letter that is found on the keyboard, that is English language keyboard, there is a code available. When you say it's a character, on the screen also, you will not find the number 65 appearing on the screen. You will find a letter A appearing on the screen. So here I have a table or a chart of ASCII characters. So let us look at this table from here. See this. This is letter A. Letter A, its decimal value is 65. And letter B, its decimal value is 66. C is 67. And so on. And lastly, Z is 90. That is the decimal value. But same decimal number, if you convert into hexadecimal, then alphabet A is 41. Uppercase A is 41. And this uppercase Z is 5A. This is the hexadecimal form of that same 90. So 90, if it is converted into hexadecimal, it will be 5A. So the ASCII codes for the characters are 65 to 90 for uppercase of English alphabets. But English language is a bicameral language. Bicameral language means a language which have letters for upper cases as well as lower cases. So mostly the Latin based languages are bicameral languages. Every language is not a bicameral, means it will not have uppercase, lowercase. Like if you take Indian languages, Hindi, Telugu, they will not have uppercase and lowercase. But Latin-based languages have uppercases and lowercases. Such languages are bicameral. So for lowercases also separate codes are there. If you look at here in the table, lowercase a is 97, b is 98, so on. Lowercase z is 122. If possible, you try to remember capital A is 65 and capital Z is 90. Lowercase a is 97 and lowercase z is 122. If possible, try to remember this range. Then on the keyboard, you will find other things also, like numbers also. If you think this number is not a numeric value, it is a letter, picture, character, a graphics, like A is a graphics, right? So if you think that this is also a letter, a graphic, then for that also ASCII codes are there. So 0 ASCII code is 48 and 9's ASCII code is 57. 48, 49, 50 up to 57. So numbers also have codes available. Now you can see these are all special characters. Space, it is 32, exclamation, it is 33, and rest of the things. You can see all the characters. Then here if you see, what is this? Start of heading, start of text, inquiry, bell means beep sound in your computer system, backspace, that is for deleting a letter, line feed, vertical line, cancel is there, escape is also there. Actually these characters are non-printable. These are the control keys on the keyboards. Like arrow keys are there, those are the control keys. Device control key 1 2 3 4, these are arrow keys. And enter key, backspace, escape, all these are control keys. They are not character keys. It means they are not printed on the screen. When you hit A from the keyboard, A will appear on the screen. But when you hit shift, nothing will appear on the screen. So shift out, shift in, these are nothing but control characters. Escape is a control character. So there are codes available for control characters also. Just you should remember this one. You should know this one. So ASCII codes are available for English uppercase alphabets, lowercase alphabets, and digits, as well as the special characters found on the keyboard, as well as the control characters that are available on the keyboard. So if you see, ASCII codes are ranging from 0 to 127. So total how many? 0 to 127 means total how many? 128 codes are there. So ASCII codes are from 0 to 127. Total 128 codes are there. 128 means 2 power 7, because these are all represented finally in the form of binary. Binary means 2 digits. So 2 power 7. So 7 means what? 7 bits. 1, 2, 3, 4, 5, 6, 7. So within 7 bits only ASCII codes can be represented. Any of this ASCII code, if you convert into binary form, then the binary digits will be not more than 7 digits. Like if you take 65, it will be 1000001. This is the binary form of 65. So if you want to store ASCII code of any of these letters in memory, then how many bits are enough? 7 bits are enough. But 7 bits are never allocated. Memory is allocated in the form of bytes. So we say 1 byte is enough for ASCII code. 1 byte makes how many bits? 8 bits. So this is all about ASCII code. Now I'll just give you a demo and I'll explain something more about this one. Let us open ideally. Here I will take a string and I will take a letter A and I will call function ord of s. You can see that it is giving me 65, that is the ASCII code of capital A. So if you take a single letter in a string and call ord function, then it will give you the ASCII code. So if you take anything as assign, in this, if you take just a space and enter, then call ord of s, then you get 32, that is the ASCII code of space. If you know the number, then you can call this function char of 65. You know the ASCII code. Oops, I misspelled this one. The function is chr65. So if you know the ASCII code, then you can get the alphabet for this one. See, I have misspelled this one. I have given AR. So it is giving me the error that name char is not defined. So if you do mistakes, you get the error. So you should get used to with the errors also. You should know what error you get for a particular mistake so that you can correct your mistake. So chr is a function available. If you give the ASCII, you will get alphabet. And ORD is a function where if you give an alphabet, it will give you ASCII. So let us go back. So I have explained you about the ASCII code. See, from the beginning of the computers have been supporting English language alphabets, and the ASCII codes have been made as standard code, that is universal code. Every machine in the world follows the same code. 65, when it is said that it is not a number, it is a character, means it is A. So the code for alphabet A is 65. Likewise, the codes are given for all the keys. Now this is about English language only. Now, with the start of internet, the computer started supporting all other natural languages like Greek, German, Hebrew, Arabic, Hindi, Telugu. They started supporting various natural languages, and the script for various languages is different. Now every language have different number of letters and the special characters. Now to support those languages, new codes are defined that are called as Unicode. I will break the topic into two lectures because the video will become lengthy. So this is about ASCII code. I have explained you. Now in the next lecture, I will continue and I will explain about the Unicode. So that's all in this video.